Today we're going to be looking at the scalar product. So we have looked at vector addition and subtraction. We're now going to look at vector multiplication. Now there's two ways to multiply vectors. One is using something called the cross product, and this gives us a vector. And the second is called the dot product, and this gives us a scalar. The dot product is also known as the scalar product. Now in this course we do the dot product, the scalar product, we don't do the cross product. And so we would say we had two vectors A, and then you do dot B for the scalar product, and this would be A times B cross. That's where the cross comes from. So the scalar product also allows the angle between vectors to be calculated. So let's think about two vectors. So let's say we've got a vector here and we've got a vector here. And these are both, remember, vectors have a direction and they have a magnitude. And on these vectors, this is our origin and the direction is away from the origin in both cases, and therefore we can define theta. Let's think of another angle. This time the direction is both coming towards some origin point here, and this is angle theta. So we define the angle between vectors as the angle made either when direction of each vector is away from the point or towards the point. So this is away from the point and this is towards the point. You wouldn't define the angle like that, where you've got one coming in and one going away. That's not how you define it. So we know we've got the magnitude and the direction of our vectors, and the scalar product is a multiplication that is in relation to a particular direction. Now we're going to think of a problem in that if you've done mechanics, this will make a bit more sense to you. But we're going to think of a real life kind of problem, and we're going to be taking this problem, and then from this the scalar product will kind of fall out of it, and we can then turn this into a general case. But this is just to give us an indication of what's happening. So we've got some load here, and somebody is pulling this load, and they're pulling it with it doesn't matter. So he's pulling it with this in this direction with vector A. This is the force with which he's pulling this load here. That's meant to be a straight line. Now the direction of displacement is in this direction, which we're going to call B. So this is the direction of pull, and this is displacement Now let's just draw this in a nice little right angle triangle. You've got theta, you've got theta here. Now we've got the magnitude of the force that the guy's pulling with is going to be the magnitude of vector A. Now, because he's pulling it at this angle, theta, but the displacement is parallel to the ground, it's being slid across the ground, not all the force with which he pulls is going to be used in this direction that the displacement is used in. There's a component of force which is used in the x direction to pull this box along, and we call that x. And x is going to be the magnitude of the total force times cos theta. Now, if you want to think of the work done by the person, now the equation for that is force times distance pulled. So the work done is going to be this component of force in the x direction times the magnitude of the displacement. And this here is essentially, we can rearrange it, this here is essentially the product rule. So the general product rule is the scalar product of two vectors, or the dot product of two vectors A dot B is equal to the magnitude of vector A times the magnitude of vector B cos theta, where theta is the angle between the two vectors. So let's do an example to see how we can use this, because as I said previously, we can use the dot product to calculate the angle. So we've got vector P, which is 8 minus 6 minus 10, vector Q, which is 4 minus 3, 0, with angle theta equals 45 degrees between the vectors. Find the scalar product. So we've got P dot Q is P Q cos theta. So firstly we need to find the magnitude of these two vectors. So P is going to be 8 squared plus minus 6 squared plus minus 10 squared square rooted, and that's going to give us 10 root 2. And the magnitude of Q is going to be 4 squared plus minus 3 squared plus 0, and that gives us 5. So we'll have 10 root 2 times 5 cos 45. Working all that out, we'll get 50. This looks like 56, but it's 50. Now, let's think of a couple of special cases. Let's think we've got two vectors that are parallel. So, A dot B, magnitude of B, cos. Now the angle between them is going to be either 0 or 180, which is, that's going to be 1. So A dot B is just going to be the magnitude of A multiplied by the magnitude of B. Now, if you've got two vectors that are identical and they're parallel to each other, their dot product will just be the magnitude of A squared. Our second special case is when we have perpendicular vectors. So right angles 90 degrees and the cos of 90, theta is 90 or pi over 2 radians, cos of theta is going to be 0, so A dot B will equal 0. Now it's important to remember this, that with parallel lines, you've got A dot B is just the magnitude of the two vectors, and when they're perpendicular it's 0. We can also do the scalar product for component form. So we don't need to know the angle between them. We can still find the scalar product and we can use that answer to then calculate the angle between them. So let's say we've got vector A, and that is A1i plus A2j plus A3k, and we've got vector B, which is B1i plus B2j plus B3k. And now we want to do A dot I. So that is A1i plus A2j plus A3k multiplied by I plus B2j plus B3k. Now what we do is we just break open the brackets. That's a big horrible thing with three coefficients in each of the brackets. So I will write this out. We will get, I'm not going to do all the working, I'll just write out the actual answer. A1i dot I plus A1b2i dot j, underline the vectors just to make them stand out, plus A1b3i dot k plus A2i b1j dot I plus A2b2j dot j plus A2b3j dot k plus A3b1 k dot I plus A3b2 k dot j plus A3b3 k dot k. Now let's think of our unit vectors. Let's just draw them here. We've got I, we've got j, and we've got k in the perpendicular. So what did we just say? Vectors that are parallel, so I dot I, j dot j, and k dot k, they're all parallel. So theta equals 0, therefore cos theta equals 1. So these are all going to equal 1. However, any other combination, so I dot j, I dot k, and so on and so forth, cos theta is going to be 0 because theta is 90 degrees. So I dot I is 1, that stays. This is going to be 0, this is going to be 0. J dot I is going to be 0, J dot J is 1, J dot K is 0, 90 degrees. K dot I, the angle between them is 90, so 0. K dot J, angle between them is 90, so 0. And that leaves us with this. So all of that comes down nicely to give us the dot product rule in component form is A1 B1 plus A2 B2 plus A3 B3. Nice and simple. So that is equal to the magnitude of A times magnitude of B cos theta. So let us use this for a couple of examples. So we have vector P, and it's 8I minus 6J minus 10K, and its vector Q is 4I minus 3J. And we want to show that theta, the angle between them is 45 degrees. So first we need to find the dot product. So it's going to be P1 Q1 plus P2 Q2 plus P3 Q3. So that is 8 times 4 plus minus 6 times minus 3 plus minus 10 times 0. So that gives us 50. Now we need to find the magnitude of P. So that's going to be 8 squared plus minus 6 squared plus minus 10 squared, which gives us 10 root 2. And now the magnitude of Q, which is going to be 4 squared plus minus 3 squared, which gives us 5. So we know that P dot Q is the magnitude of P times the magnitude of Q cos theta. The dot product is 50, and then we've got 10 root 2 times 5 cos theta. So 50 over 50 root 2 equals cos theta. So theta is going to be the inverse cos of, so the 50 cancel out, 1 over root 2, which is 45 degrees, which is what we want. Let's do another one. Relative to the origin, the position vector of A and B are OA is 5 minus 2, 4. OB is going to be minus 1, 3 minus 1. I want to find OBA. So here's our origin, and we want to find O, so this is going to be BA. And this line here is OA. So this is origin. So we know the vector OB, we know OA. So we know this one and we know this vector, but we don't know A, B. So remember, the vectors have to be in the same direction. So to find the angle OBA, we need the vector AB to be coming towards point B, because OB is coming towards B, so this has to come towards B for this angle here. Okay, so we need to find vector BAB. So vector A to B is going to be A to O plus O to B. So vector A to O is going to be negative OA. So we've got OA, so we just need to, so minus 5, the minus 2 is going to become 2, plus 4 is going to become minus 4, so that's AO, and then OB is minus 1, 3, 1, so this gives us vector minus 6, 5, 5, a minute, oh it's a minus, sorry, minus 5. I didn't copy that down right, so that's there's a minus 1 in there, it doesn't show up very clearly. So we now have vector AB and we have OB. So we want to find OB dot AB. And so we're going to use the components dot product. So we'll have minus 1 times minus 6 and 3 times 5 plus minus 1 minus 5, and that's going to give us 26. Now we need to find our magnitudes. We need to find the magnitude of vector AB. So that's going to be, so this is vector AB, so it's going to be minus 6 squared plus 5 squared plus minus 5 squared, which gives us the root of 86. And we need to find the magnitude of vector OB. Which is minus 1 squared plus 3 squared plus minus 1 squared, which gives us the root of 11. So we know that 26, the dot product, must equal the magnitude of AB, the magnitude of OB, cos theta, so that's root 86 times root 11 cos theta. This is our theta. Working all that out, we get theta as 32.3 degrees. So I hope that makes sense.